Hello students, welcome back to Dr. OJ's tutorial class. In this video, we shall talk about the trigonometric ratios of an acute angle. Stay blessed. Now, what is an acute angle? First of all, an acute angle, you could recall, is an angle that is greater than 0 degree but less than 90 degree. Again, an angle that is greater than 0 degree but less than 90 degree. So, let's consider a triangle ABC with the following size. That is, let's say we have this triangle. This is ABC, and let our triangle be a right angle triangle. Let's say consider a right angle triangle. Let's say a right angle. Consider a right angled triangle. Okay, let's rewrite this. Consider a right angled. Consider a right angled triangle ABC. That's much more better. That statement is much more better. Consider a right angle triangle ABC with the following size. Let's say here we have R. Let's call this X and let's call this Y. So this is the angle we want to actually discuss. Angle. This is an included angle that I want to refer to. Our reference angle here is this. This is our reference angle. Now, if we apply our previous knowledge of so couture, which is sine for so, opposite over hypotenuse, cos for car, that is CHA, adjacent over hypotenuse, and the tour, that is tangent. The tour is tangent, that is opposite over adjacent. So couture. Now let's start with so, where we have sine theta. Don't forget, the side that faces your theta, the reference angle, is the opposite side. The side that happens to be the longest one is the hypotenuse side. Don't forget that. You must have learned that in Pythagoras theorem. While the last side is called the adjacent side. So in this case now, since so means opposite over hypotenuse, that means what? Y all over R. That's our sine theta. Then cos theta will be adjacent over hypotenuse. That's X all over R. Y tangent to R. Tan theta will be opposite. That's Y all over adjacent. Our adjacent is X. Now let's look at this critically so that we have gotten ratios for each of these trigonometric functions or trigonometric values. Now let's see if there is a relationship between one or two of them. Let's look at them. I want to see if there can be a relationship between one or two of them. Now let's divide sine theta by cos theta. Divide sine theta by cos theta. We get, let's try it. Let's try that. I hope you are taking notes. Our sine theta is y over r. That is y all over r divided by x all over r. So if we divide that, we have y all over r times r all over x. And that gives us y over x because r will cancel out. So and y over x is equivalent to tan theta, which we have obtained before. Therefore, tan theta is what? Sine theta all over cos theta. That is, if you divide sine theta by cos theta, you get tan theta. Now we can move forward and look for other trigonometric values in the process. So we have what we call sec theta. That is 1 over cos theta. Sec theta is 1 over cos theta. Let's check it. This is what? 1 over, our cos theta in that in that for our previous example is x over r. So that's 1 over x over r. By the time you divide, that is 1 over 1 divided by x over r. That will be 1 over 1 times r over x. That will give us r over x. That's the value of what? Our sec theta. Why cosec theta? Cosec theta will be 1 over sine theta. That is, cosec theta is the inverse of sine theta. Sec theta is the inverse of cos theta. Okay, this will be what? 1 all over y over r. Okay, and that will be what? 1 over 1 divided by y over r, which is 1 over 1 times r over y. You obtain it, but you obtain it by the time you change division to signs. This will give you r over y. That will give us r over y. So, we have gotten that. We can also obtain another ratio, which is in relation to tangents. You can have an inverse of tangent as well. That is called cos theta. Cos theta. Cos theta. Cos theta. That is 1 over tan theta. And don't forget, that will be what? 1 over, what was our tan theta? Y over x. Y over x. That will be what? 1 over 1 divided by y over x. And that gives us 1 over 1 times x over y. So we have x all over y. So cos theta is the inverse of tan theta. Let's continue. Let's try. We are trying to explore every possibility of the trigonometric ratios that we can lay our hands on as far as this video is concerned. So I hope you are taking note of the value of each of these ratios. Okay. Now let's look at sine theta. Sine theta is let's take sine square theta first. Sine square theta will be sine theta square. Cos square theta will be cos theta's square. I hope you understand. Fine. Now, how do we go about? There's also a relation between the two of them. Let's check. Our sine theta was y over r. So since sine theta equals to y over r, so sine square theta will be y square over r square from here. Because if I say sine square theta is sine theta square, so and I say sine theta is y over r, sine square theta means sine theta times sine theta, which I have explained here. Okay. So also, since cos theta is equals to x over r, cos square theta will be x square all over r square. Let's add them together and see. Adding them together. Let's call this one equation 1 and equation 2. Adding equation 1 and 2. Adding equation 1 and 2 gives y square all over r square plus x square all over r square. Yes. So that will give us what? SCM is r square. R square and r square 1 times y squared plus r square and r square 1 times x squared. Now we obtain x squared plus y squared plus x squared over r squared. But we could recall, let's look at something. In our previous right angle triangle ABC, we could recall that. We call this one r, call this one y, we call this one x, and we call this one theta. Now, if we want to solve this, any of these sides could be found using Pythagoras theorem. So recall, let's call this one equation 3. Recall from Pythagoras theorem. Pythagoras theorem, that says the square of the hypotenuse, that is r square, because this hypotenuse side is always the longest side in a right angle triangle, is equals to the sum of the squares of the other two sides, that is y squared plus the other side is x squared. So now you go see clearly here that our r square is the same thing as y square plus x squared. So let me call this one equation 4. Now if we now put equation 4, into equation 3, putting equation 4 into 3, putting equation 4 into 3 will give us what? Let's check. No, equation 3 says that what? It says that y squared plus x squared all over r squared. So that implies, and equation 3 says wherever you see r squared, you write y squared plus s squared. Or wherever you see y squared plus s squared, you write r squared. So that means this one what? Y squared plus s squared is the same thing as r squared from here now. So there's r squared over r squared. So by the time you divide r squared by r squared, you have 1. So that implies that sine square theta plus cos square theta, you know sine square theta stands for y squared over r squared, while cos square theta stands for s squared over r squared. That implies, this now implies that sine square theta plus cos square theta is equals to 1. Is equals to 1. So this is a very good identity. It's a very good identity. So we can also equally have other values. In other values, you can have other values like you see, let's say 1 plus, we want to check 1 plus sec square theta. 1 plus tan square theta equals to sec square theta. Is that possible? Let's check. Let's check this. Now we have our tan theta is, recall, say since tan theta equals to, I think what do we get for tan theta? Y over x. Good. So then sine tan square theta will be square of this y square over x square. Fine. So checking 1 plus tan square theta equals to x square theta. Let's check. Therefore 1 plus this now y square over x square. Let's find out what will it give us. What will give us? LCM here is x square. Fine. 1 in x square is x square. X square times 1 is x square plus x square in x square is 1 times y square. Fine. So we have x square plus y square equal over all over r square over x square. Sorry. So now recall from our previous calculation where we use Pythagoras theorem. You know, we said r square and x square plus y square is equal to r square. So this one means r square all over x square. Yes, because from our Pythagoras knowledge, which I just solved for us. Okay, now let's check sec square theta. What is sec theta? Sec theta is, recall that sec theta is equal to what? 1 over cos theta. That's our sec theta. So which is what? Which is 1 over, and we have already previously obtained sec theta as what? R over x. Yes, I think we get R over x as our sec theta. You can check from the video. We get R over x. So sec square theta will have what? Sec square theta will be R square over x square. If sec theta is R over x, square it with this. So that means comparing this with this now, you can see that this implies that this statement is correct, because it implies that what we have here, this what we have here is now what we have here, which means 1 plus tan square theta is equals to sec square theta. So we have established the proof that is 1 plus tan square theta equals to sec square theta. So this is correct. This is correct. We can also have other two identities. We can have this as well. We can have 1 plus cot, or say yes 1 plus cot square theta is equal to cosec square theta. You can check that 1 plus cot square theta equals to cosec square theta. So you can check that. It's very simple. You know what cot theta means? Cot square theta is cot theta square. So add 1 to it, you get cosec square theta. So on this note, we want to draw the curtain here. So in the next video, we shall illustrate all these concepts with the examples. Thank you.